Let's take a look at 3 different ways that we can prove that a quadrilateral is a parallelogram using coordinates. The first method that I'm going to show you is going to use the property that diagonals bisect each other in order to prove this. To show that diagonals bisect each other, what I'm going to do is I'm going to find the midpoint of each of the diagonals. And what I want to see happen is I want to see that the midpoint's in the same location for both of the diagonals. So let's go about doing that. If you forgot the midpoint formula, I've written it down up here. I remember it was to add up the x coordinates and divide by 2, and then add up the y coordinates and divide by 2, basically find the average of x and y. So let's go ahead and do that. I've also written down my coordinates already on my figure. So let's find the diagonal from, let's use the diagonal from O to M and find its midpoint first. So I'm going to add up my 2 x values, which are 0 and 7. So I'll add those up and divide by 2. And then I'll add up my y coordinates, which are 0 and 4, and divide by 2. And of course that's just 0 plus 7 will just be 7, and 4 divided by 2, or 0 plus 4 is just 4. So once I find this midpoint, I come up with 3.5, comma 2 once I simplify this. So there's my first midpoint, and I can see from the graph that that's about where that midpoint's located. We need to find the midpoint of the other diagonal as well and show that it's the same thing. So let's find the midpoint of the segment LN. Again, we're going to use the same formula, so add up your x coordinates, which are 1 and 6, and divide that by 2, and then add up your y coordinates, which are 4 and 0, and then divide that by 2. And so 1 and 6 gets us 7, and half of 7 is 3.5. And then 4 and 0 is 4, of course, divided by 2 is 2. And so I found both midpoints, and what I can see is that both midpoints of both diagonals are exactly in the same location, meaning the diagonals bisect each other. So that can serve as my proof that this is in fact a parallelogram. A second way that we can prove a quadrilateral is a parallelogram is by using the property that opposite sides are congruent. And so what we'll do in this example is I'm going to show that opposite sides, the top side and the bottom side, for example, are the same length or distance, and then I'll show the left and the right sides are also the same length. So we need to use the distance formula to do this. I've written down the distance formula if you've forgotten what it was. Otherwise, you could use the DMS program that I gave you in class to make this problem a little bit easier, because it will be a long method to prove this. We have to find the length of all 4 sides and show that opposite sides are congruent. So I'll do one of these by hand, and then I'm going to skip and use the DMS program. So let's find the length of segment AB. So to find the distance of that, I'm going to subtract my x values. So I've got -3, minus 2 squared, and then subtract your y values, so 3 minus 5 squared, and let's go ahead and simplify that. So I've got, in parentheses, -5 squared, make sure you keep that in parentheses, plus -2 squared, and let's keep simplifying. So -5 in parentheses squared means multiply -5 by itself, so that's 25. Same over with this next part, multiply -2 by itself, so that's a +4, and I end up with the square root of 29 as the length of side AB. So I'm going to label that in my diagram. That's the same process you need to do for all 3 sides. So either if you don't have the DMS program or don't have a way to find the distance or length of these sides, then you need to go ahead and continue using that formula. Otherwise, I'm going to kind of cheat, I guess, a little bit, take a shortcut, and I've already gone ahead and used the DMS program. I found these distances. I did the same thing. I found segment DC was also square root of 29, which is what I wanted to have happen. I want those opposite sides to be congruent. And then what I need to do is I need to find the remaining 2 sides. It's not enough just to find that one pair of opposite sides are congruent. I need to find the other 2 as well. So I need to find the length of segment AD, and I need to find the length of segment BC. And once again, if you don't have the DMS program or some program to use, you would need to use the distance formula and repeat what we just did. Again, I'm going to kind of use my resources, not cheat, but use my resources, and I found out that those 2 segments are the square root of 18, and the other one was also the square root of 18. And so what I see here is that I have one pair of opposite sides that are congruent, and a second pair of opposite sides are congruent. Therefore, this figure is a parallelogram. And the final method that I can use to prove a quadrilateral is a parallelogram using coordinates is to show that opposite sides are parallel to each other. To do that, I'm going to be finding the slopes of all four sides. And you may recall that parallel lines have slopes that are the same. So what I'm looking for is I want to find the slopes of the top and bottom to be the same, and I want to find the slopes of the left and right side to be the same. If you forgot slope formula, it's up here, y1 minus y2 over x1 minus x2. I would need to do that all four times to find the slopes of all four sides. If you have the DMS program, you can do that. And you may recall as well, another way to find slope is to just count the rise over run, which may actually be the quickest way to do this. So let's go ahead and I'll kind of show you my work for one segment, and then you guys can find the other segment slopes for yourself. So let's start with AB. So if I'm using my formula, I'm going to subtract my y values, so 5 minus 3. And divide that by my x values, which is 2 minus negative 3. And once I simplify that, I end up with a 2. I end up with a 2 on top, and then 2 minus negative 3 is a 5 on the bottom. So that first segment, segment AB, has a slope of 2/5. Now, like I said, you could also find that slope using just rise over run, which I said maybe even quicker. So put points at A and B, and turn that into a triangle, a right triangle, and I can see that my rise is 2, I've counted up 2 spaces, and my run is 5, so rise over run will get me 2/5 as well. So I would probably just do that. That's going to be easier than using the program or using the slope formula. So let's go ahead and find segment DC. I want to show that they have the same slope, and again I can count my rise over my run and see that that's up 2 and over 5. So those two segments have the same slope, meaning those two segments are parallel to each other. It's not enough just to show that, though. You have to show all four sides, and both pairs have the same slope. So let's switch over and do segment BC and show that it has the same slope as segment AD. So again, we can count rise over run. Notice the line is decreasing this time, so that's going to have a negative slope. I can see my rise is 3, and my run is backwards as a negative 3. So if I set that up, I've got a rise of 3 over a run of negative 3, which simplifies to negative 1. And then similarly for side AD, I can see that I have a, rise of negative 3 if I count downwards, and then a run of 3. So a rise over a run, negative 3 divided by 3 is again negative 1. And so what I can see again is that those two segments also have the same slope, meaning those two segments are going to be parallel to each other. So I can see that I have two sets of parallel sides. The left and right sides are parallel, the top and bottom sides are parallel because they have the same slope, meaning this figure is a parallelogram.